sometimes look a little bit different and they're a little bit more confusing to look at. So make sure that you're comfortable with this. Again, anything near the X is going to have a horizontal in your little parentheses. Outside of it, the plus, the minus at the end, that's a vertical. The reflections work the same way too. Basically, start with your basic sketch. Don't depend on your calculator. Your calculator does a terrible job. Remember, it kind of just looks like it stops off there. So remember your basic rules. Your domain, your range, your natural asymptote is your y-axis, that's where your x is equal to 0. That's a natural asymptote. And your x-intercept is at 1, 0. This is your basic log graph, whatever base we were in here. These are the basic attributes of your logs. Now, all this is saying is, okay, it's not near the x, it's near the y. So if the y goes from positive to negative, where is my reflection? Where did I pass over? The x-axis. So I have a reflection in the x-axis. It's not going to change your domain. You didn't do anything horizontal. And in this case, it's not going to change your range because your range is all real numbers. So your intercepts, everything else will stay exactly the same. Asymptote, intercept. Okay, so I'm looking for a sketch when you do this for me tomorrow. If you give me this, that's not a log graph. That's what you took out of your calculator. It looks like it's stuck right at that axis. It is not. Remember, it comes from here. So don't give me that little piece here because I'm going to mark that wrong. I want your sketch of a log. ln and logs work the same way. Your natural log is very close to your base 3. So they work exactly the same way. So again, start with your natural log. Just start with your basic graph. Start with your basic graph. Here it is in the blue over here, or whatever color is this, black, I think maybe. This is your natural base, your log. Now, you're going to shift it horizontally 4 units to the right. If you keep track of your domain, your range is not going to change right now. So that's not going to change. Keep track of this, keep track of this, keep track of this. If you add 4, like this will help you find your parts. So now your new domain, after we did this shift of 4, after we did a horizontal shift of 4, your new domain is from here to here, your new asymptote is here, and your new intercept is here, so far. Then we're going to take a vertical shift up 2. Does a vertical shift up 2 affect this domain? No. So we've got the same domain now. Did it affect my asymptote? No. I've got this asymptote. It did, however, affect my x-intercept. My x-intercept now had to move up off the 4, 0, wherever we were at. It did change my x-intercept. It did, however, change my x-intercept. Your x-intercept and your y-intercept you're going to have to find for me algebraically anyway, if possible. So my x-intercept says, set my y equal to 0. So go back to your original equation, set that y equal to 0. Now, solve this. This is one type of your equation when you have a log on one side of the equal sign. So get the log by itself, subtract 2. If it helps you, turn this around. When I have a log on one side of the equal sign, my goal is to flip this to an exponential equation. I can't take my log away. I can't add a log to the other side. I know that my base is e, so I say e to the negative 2 power is equal to x minus 4. And I'm going to flip this around. If you can't do this with your If you can't just take this, add 4, that's your exact value. You'll have a calculator to do this, so then you just have to enter this in your calculator. And I don't think I asked you for it. I don't think I asked you for it, but you have to do it on the, I didn't ask you in your review, but if you have to do it in the, on the test, you're going to have to set it up that way. So let's do e to the negative 2 power plus 4. So my intercept is about 4.135, and that makes sense. Make sure it makes sense to you. Make sure that it's sensible. Because I could see slightly, but when I moved it up, it just kind of moved a little bit over off the 5. And does that make sense? Absolutely. I know I didn't ask you for it here, but just so that in case it's on the test, you have to find the asymptote, you have to find the intercept. Okay? Questions at all on the transformation? Okay. All right. These were using your rules. You're either going to condense your rules or expand your rules. There's no equal sign here, so you're not solving anything. You're just giving me a condensed expression with the 1 log word. When I ask you to expand, you're going to take that 1 log word and there's going to be logs everywhere. So you can do this absolutely without your calculator. When you see logs all over the place, start like you're doing this left to right. The first thing that you say is, because logs are exponents, when I added my exponents, what was I doing? Multiplying my like bases. So I'm going to turn this into a multiply first. Do it in 1 step at a time if you have trouble. Now, when I was subtracting my exponents, what was I doing? Dividing. I had a quotient rule here. So now, read it left to right and just make a quotient. When you finish this, you should have only 1 log word here. You're condensing this down to 1 log word. Normally when we start with 1 log word, then we expand it out. This guy you're condensing down to 1. Remember, before you do this, anything in front of a log word, you got to get rid of. It's got to say log, 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 before you can do anything. This guy came from its power. So move that up first. You will always have the same base in your log statement, because otherwise it won't work. You can't combine 2 different type bases in a problem. So we're going to pull up your exponent. We said, oh, when we were subtracting, we were dividing our bases. So we're going to turn this into a divide.
So you can only have 1 log word 1 time?
1 time. You're condensing. Now, this guy, do this first. It's in parentheses. Bring up the 3. What was I doing when I added them? Oh, I was multiplying. So I'm going to have log x squared minus, and I got to multiply, log y times z cubed. Oops, nope, y cubed. I wasn't even close. Y cubed z. Okay, do 1 step at a time. Then I notice, oh, I have a subtract. So my bases are all the same. I moved up my exponent already. So I'm going to take out my log word, and then I'm going to build a subtract. If you're more comfortable putting parentheses around your denominator, you can absolutely leave your parentheses there. Good? Okay? Next, you're expanding. So now you're going from 1 log word to logs everywhere. So undo it as if you were solving this problem, and undo it from the last thing that you did. So if the first thing I did was plug in an x, and I multiplied, the last thing I'm going to do is divide. So undo the divide first. When you divide by bases, you subtract the exponents. Turn it into a subtract. Then you can move power rule, move this guy up. Then you're over here. Oh, this is a product. A product, when I'm multiplying my like bases, I turn into an add. So you could set it up like this, or you can then, in this case, you absolutely need your parentheses here, because you're going to take this product and then do the subtract. If you want to get rid of your parentheses, you have to distribute that negative sign. So either way you want to leave that. I would just leave it like this with the parentheses around it. That's fine too. Usually, like if the add comes first, we don't need parentheses because order of operations says do this first. Okay? If you're going to get rid of the parentheses, just watch the distributors part. The next one, you have a product. Product says add. Separate that into an add, and then bring down your power. That square only belongs to that m. It doesn't belong to the 4. So you can't bring it down first. It only belongs to the m. So separate the product first. Are we okay so far? Okay? Now comes this big one. This is where the root rule comes in handy. I need to get rid of my radical sign. I need to make it into an exponent. Somewhere, something is really going on here. I don't know how this happened, so just give me 1 second. That's going to upset everything. It was hooking up to my other one that I had open here. I don't know why. Okay. So here we were. Now, this says find the log of r. Well, if I say log of r here, if I put logs on one side of the equal sign, then I have to put log on the other side of the equal sign. But I have a radical here. So the first thing I want to do is get rid of the radical. This is the root rule. And a cube root makes you have an exponent of what? This whole thing in here is a 1. 1/3. Okay, a square root gives you what exponent? 1/2. A fourth root, 1/4. So now I'm looking at this. So now, do you see where your exponent is? It includes this whole thing. Now bring your exponent down. Okay, and work from inside here. The first thing you want to do is undo your division. Undo your division. Keep your 1/3 out here. It's going to be 1/3 times everything. Excuse me. Sorry. So we're going to take 1/3. We're going to just leave our 1/3 out here. So subtract. Do your division first. Okay, and then work from within. Keep your 1/3 out here. This is a product. What was I doing when I was multiplying my like bases? Adding. And then once you separate them, you can bring down your square. It only belongs to your a. So 2 log a plus log b minus log c. I don't need parentheses within that inside one unless you want to put it there, because it'll automatically do your add and then your subtract. Now, the only difference is leave your 1/3 here or distribute the 1/3 all the way across. The 1/3 applies to the whole entire thing. I'll just leave it like that. Because if you do the 1/3 and you multiply it by 2, you kind of just lost your exponent there. It's harder to bring it back. good with this? This was a long one. Stop me if you're not getting it. All right, then you have a bunch of equations. And I'm going to give you the same kind of setup. I'm going to set it up where there's no logs, and you have to put logs on both sides, where there's a log on one side, and then where there's a log all over the place. So, first time around, there's no logs here. I could try to say, can I drop 24 down into a base 3? Can I do 3 to the something power to give me 24? No. If I could flip it to an exponential equation and then solve it, but I can't. So therefore, I have to have some way to get that exponent down. That's your power log. So you have to put the logs on both sides. Now, I could use ln, or I could use log. If you prefer to use log, it works the same exact way. What you put on one side, you have to put on the other side. This exponent can now come down. Now, your goal is to solve for x. So therefore, these are products. Divide by whatever else is around it. Just watch the denominator. If you don't use your fraction key, make sure you put parentheses around that denominator. Whether you use ln or whether you use logs, you'll come out with the same answer. The log is just another base, basically. So they all work the same. This guy over here, kind of tight in here. Same thing. I definitely can't bring 142 down to a base of 8. Not happening. So I have to have a way to bring this down. Oh, it's my log power rule. But this is base 8. Base 8 has to use ln. ln of both sides. Now I can bring down my exponent. And what happens to ln 8? Cancels out. That's one of my properties. Good. And this is kind of nice. Just divide by 7, divide by 7. And remember rule of thumb? 3 decimal places. So you're guaranteed to see one of that type. That's the type without any logs there. And a type that I won't be able to flip back to an exponential equation. 11 is not very different, except I just added a couple of more obstacles here. You want to isolate this guy. So the first thing you want to do is subtract 15. You want to isolate this, so divide by 3. Now, leave it.
Divide by 3 the first time?
You could the first, well, you could divide by 3 if you divided this also, the 15 by 3. So if you wanted to divide every term by 3, you could. But I would wait till it's isolated first and then divide by 3, but that's up to you. I would leave this, 10 over 3. Don't put that into a decimal, because it does not terminate. At the end, you do all your rounding. So now, you've got e to the x equals 10/3. A little strange looking. I got to get that x down somehow. What's going to get that x down? Power log, ln, good. ln e to the x, ln 10 over 3. When this x comes down, what happens to ln e? Crosses out, good. Look how nice that is. Just put that in your calculator. Don't do your rounding until the very, very end. Let your calculator do all the rounding at the end. Another type of log equation you have logs on one side. I got to tell you, this one is usually the most confusing for kids. Because what do I do with this? I can't put a log over here because it's an equal sign. I'd have to put another log over here. So I'm going to condense this guy into one term. Then after I get a log on one side, I'm going to flip it to an exponential equation. So using your rules, what was I doing when I added my exponents? When I added my exponents, what property what was I doing? Multiplying. So I'm going to turn this guy into a product, right? Now I have this. I still only have logs on one side, but I'm going to use log equals exponent. Don't worry about this mess in here. Just keep that argument right there. So I'm going to get rid of my log by flipping it to an exponential equation. My base is 2, my exponent is 5, and I'm equal to, yep, this mess right here. So I know I can solve this. I just made an algebraic equation with no logs in there. So I take 2 to the 5th, that's 32. I distribute this guy. Whenever you have descending x's, you have a quadratic. Get everything to one side and set it equal to 0. Factor, and don't forget to check. Because your domain of a log is 0 to infinity, it cannot take the log of 0. It cannot take the log of a negative number. So check these guys. If I stick a -4 in here, in this x, I can't take the log of a negative number. So I reject that one. And my 8 says this one would be okay, and this one would be okay. So there's my answer. That's probably the hardest one when logs are on one side, because you're going to condense that to one log statement, and then you're going to flip it to an exponential equation. What I would caution you also is sometimes there's no base here. If there's no base and we came out like this, how would I flip this to an exponential equation? 10. Good. It's automatically base 10 when it's not there, right? So I need to do 10 to the 5th equals this. If I was in ln, how would I flip my ln to an exponential equation? E. My base on ln is e. E to the 5th equals this. So just be aware if your base is not there. Your base on a natural log is e. Your base on a regular log or a standard log is base 10. Last one here. This has logs on both sides. Logs on both sides is the third type of equation. So you want to bring it down to where it says log equals log, one term, one term. You're going to condense this side. You say, oh, what did I do when I divided? Oh, so when I subtracted, I was dividing. So bring this down to a divide. Bring this guy up here. Now, once you have one term, you can, on both sides, take away the log. This is one of your properties. We had a property that said x equals y. We can put the logs on both sides, or we can take the logs away from both sides. So now you have a nice little equation. Cross multiply it. Descending variables, get everything to one side and factor. And just watch the negative. If I bring a -3/4 in here, it's going to say, whoop, I don't like that negative. So reject that one. A 1 would work here and a 1 would work here. Good? Yes.
For the next one, before we start that one, we changed it before we left.
I did. I changed it. So we're going to change it when we go over this. You're right. We changed it because I gave you the same one. All right. So let's do this next one. And we'll do that together because we changed that one. I think I changed the other one too, right?
Yeah.
Okay. So because we did this one in class, I said every hour. instead of every 6 hours. So how will I change my equation? What should I do?
You don't have to put x over a number.
Right,
You just put
I just put the x. Now that made it look even nicer. So remember, this is what you end up with, 150,000. This is your initial, y equals ab to the x. I am tripling every hour. I changed this because we did the every 6 hours in class, like Renasia said. Now,
you still have 150 on those.
good, because that x only belongs to that 3. Do not multiply 150 by 3. The x only belongs to the 3. So let's get rid of this. 1,000. Now, what should I do to get that x out? Log, good. We'll take the log of 1,000 to x times the log of 3 and divide by log of 3. And what's x equal to?
6.288 hours.
Good. This is by every hour. Good. Now, what is the log of 1,000? 3. The log is the exponent, right? So this is 1 times 10 to the 3rd. So the log is 3. So you could divide 3 by log of 3, right? If you wanted to. I mean, log of 1,000 over log of 3 is perfectly fine.
And the other one.
What did I change that to?
Yeah, you made it into an increasing.
Okay.
You said the population will be twice.
Twice? Oh, very good. So we said we wanted to know when will it be doubled. Good. Okay. So again, y equals a to the bx. What did we start with? What's our initial?
100,000.
100,000. What's our rate?
1.15, but it's 1 plus 0.15.
Okay, so we're increasing by a rate of 15%, and so it's 1 plus 0.15. We're increasing this every year. And what do we want this to end up with?
200,000.
200,000. So can we divide by 100,000 to make life easy?
Yes. That'll be 2 equals 1.
Good? And we can add those together. Or you could leave them separated. It doesn't matter. Now, how do I bring down that exponent?
ln.
Okay, let's take ln. We can use ln or log. And then solving for x, what do I have to divide by?
ln 150.
Good. And what's your x?
X equals 0.201. That's what I got. Wait, sorry.
I got
No,
0.2661.
I got 4.959. 4.59.
Okay, hang on. It's going to take a little longer to go, doesn't it?
X. Yeah, I got 4.959.
4 point, good. 4.959 years. Okay, so we had to be kind of close to the half because we didn't change any percents. So it kind of works almost the same concept, increasing, decreasing. Are you guys okay with these? Questions? Nobody has any questions for me?